10. Welcome to what I hope will be both the penultimate lesson for Chapter 9 on statistics and also the penultimate lesson that I have to deliver by video because you will be in the classroom next week. Today's focus is line of best fit. We're going to be doing questions 1, 2, 3, 4, 5. I have to change the date there. I'll do that in a moment. Today's learning intention is to have you understand that after you do a scatter plot, you can put a line of best fit into it and it can help us identify a correlation between two sets of bivariate data. Okay, so to be successfully able to do this, number one, you're going to have to plot your scatter plot. Then you're going to have to add a line of best fit, find an equation to represent that line, and then use that equation to make predictions. To help you understand how to do this, we're going to go through question 1 together. So here's my data, just called X and Y. We're going to draw a scatter plot. We're just going to describe if there's a correlation or not between X and Y. Then we're going to try and fit a line, and then we're going to find the equation for that line and use it to estimate Y and X at various points. So let's start with the scatter plot. My X-axis will need to go from 1 to 7, and my Y-axis will need to go from 2 to 5, and I might just make it the start at 0, 0, just for ease. Okay, so there's my axes, 1 to 7 along the bottom. I've done 1 to 5 going up for Y, and they start from the origin, which means that point right there will be 0, 0. Let's plot our points. So first point is 1 and 2. So X is 1, and we go up to 2. There's our first point. Next one is 2, 2, 3, 3, 4, 4, I think we'll be there, 5, 4, 6, 5, and 7, 5. Yep, right there. So the points are plotted in. You can see there's sort of a bit of a zigzag pattern up, but I'd say there's a positive correlation because as one goes up, the other tends to go up. So as X goes up, Y tends to go up. So to report, I just simply said there is a positive correlation between X and Y. I don't need to go into any more detail. Okay, now we're going to do a line of best fit by eye to the data on the scatter plot, and this is where you're going to need one of these things. This thing being a ruler. What you want to do is you want to sort of angle it so about half the data points are below and half are above as you go through it. Now, yours is going to be slightly different to mine. I might even lift mine up just a wee bit. But there we go. So I'm going to draw it like that. So how I'm going to represent it is just with a dotted line because it is approximate. It's not an exact thing. So I will do it that way. Okay. That's our line of best fit. Okay, so for part D, I'm going to show you the 2 ways to do it. Now in question 1, you only have to do it the first way I show you, which is visually. But the second way I'll show you is using an equation, which you might have to do for later exercises. All right, so for the next step, when X equals 3.5, Y is going to equal what? Now I've brought back the grid lines to make it easy for me, but I'm also going to need a ruler. And I will grab a highlighter as well on the skinny setting. All right, so I'm going to find out where X is 3.5, and I'm going to have the ruler going straight up from that. So that's that point there. Then where it meets the line, I'm going to put my ruler flat to 0 degrees and rule across, and I get a value that is just a little bit above 3. Let's have a closer look. Go away, ruler. So if that's 3, that's 3.5. It looks like it's maybe not halfway there, a little bit less. So let's just say it's 3.2. Okay, so that first example was something we call interpolation, which means we predict within where the dots start and end. It has a fair degree of accuracy. What we're about to do now is we're going to go outside the dots. we're going into an unknown zone. Now we've extended the line right down to when x equals 0, and we find that y equals 1. This is called extrapolation because we're working outside the data set. So I've gone below the lowest dot, so it's extrapolation. Okay, just to show it can work the other way, this time we have to assume that y is equal to 2, and we have to find what x would be according to a line of s fit. So, excuse the bell, don't log off just yet. We get a ruler, we get our highlighter again, or whatever color you're using, and we bring it to 2. There we go. Draw a line till it touches a line of best fit. Flip the ruler so it's upright, and draw the line down, and we end up at about 1.5. Sorry, forgive the noise as the 7s, 11s and 12s go home. This is an example of interpolation because we are working within our dots. So we see how there's a dot below us. So we're working within the data set. So it's interpolation. And finally, we've got when y equals 5.5. Oh dear, another example of extrapolation. So we're going to have to be a little bit naughty and pretend that we've made our axes tall enough. Why can't I get this to 0? There we go. Oops. Awesome. We get our highlighter, we draw across, hits the fitted line, and we drop it down. And again, I haven't made my axes big enough, but anyway, we can figure it out. The ruler will cooperate. There it is. Okay. We see it drops down to about 7.5. So this is another example of an extrapolation because it's outside of our known data values, and we're assuming that the data follows the same trend. So this is an example of extrapolation, and again, it loses accuracy compared to this one in the middle of all the data. Okay, in some of the later questions, you have to use an equation to make a prediction. So let's see how we go about generating an equation. I will use question 1 as an example, even though we're not required to do this for question 1. Okay, first step in doing this is I need 2 points, and I'm going to choose 2 points that are convenient for me. I'm going to look for 2 points that cross through an intersection on the grid. For example, this one right here. That's quite handy, so I'm going to pick that as my first point. I'm just going to highlight that in a different color, and I'm going to go further up the line. Hopefully far away I can find another point. There we go. There's another good one. I'm going to use that as my second point. So let's figure out what those 2 points are. So we've got 1.5 and 2. We've got 6.5 and 5. So I've got a pair of coordinates, and remember when writing coordinates, the x value should always go first, the y value should go second. Okay, so the equation we want is going to have to follow the format of y equals mx plus c. So we're going to have to find the m and the c. Hopefully you're reaching back into the far recesses of your mind and remembering linear equations and realizing that the m is the gradient and the c is the y-intercept. Hopefully seeing that equation has dusted off another memory where you can work out m using the rise over the run, or y2 minus y1 divided by x2 over x1 minus x1. I'm really hoping this is all coming back to you now. Next step you're going to need to do is substitute the 2 points that we picked. So the 1.5 and the 2 and the 6.5 and the 5 into that rise over run equation. So what we're going to do is this is going to be our x2 and y2, and this one here is going to be our x1 and y1, and we're going to substitute them into the formula below. So it's going to be y2 is 5 minus y1, which is 2, over x2, which is 6.5, minus x1, which is 1.5. 5 minus 2 is 3, 6.5 minus 1.5 is 4. So that means our gradients is 3/4 or 0.75 if you prefer to think in decimals. So at the moment, our equation looks like this. Y equals 0.75 times x plus c. We need to find the y-intercept. Now you can do it visually by following your line of best fit back to the y and seeing that it's roughly 1, or you can do it by substitution. I'll do it by substitution just so you know how to do it as well. So I'm going to substitute x1 and y1 into x and y in this equation, just because it's smaller numbers and easier to use. It would work equally well with the other one. Okay, so here we are. I've rewritten the equation. We have a bit of space to work. I'm going to cross out the x and put 1.5 there instead, and the y is 2. So the equation should read 2 equals 0.75 times 1.5 plus c. Now we want to get c by itself, so we're going to take the 0.75 times 1.5. Let's simplify that first. Okay, so 0.75 times 1.5 simplifies to 1.125. We're going to subtract it from both sides to find c. So what's going to happen is it's going to cancel out on this side, and you're going to be left with c, and 2 minus 1.125 leaves you with 0.875. So a little bit less than 1 when you do it by the equation. Now, you might get answers that vary a little bit from what the textbook suggests, and this is because you're doing it by eye. So there's some inaccuracies inherent in how we're doing things. The equation I generated, if you look at it as a fraction, it's y equals 3/4 times x plus 7/8. If you prefer decimals, which I do, I hate fractions, y equals 0.75x plus 0.875. So let's use the one with the decimal to do a prediction. For our prediction, we're going to let x equal 3.5. So our equation will be y equals 3. Let's use the decimal. So 0.75 times 3.5 plus 0.875. You pop that into your calculator and you get your answer, which is 3.5. Okay, so that's a prediction using the equation. That was a little different to the prediction drawing on the line. We found it was 3.2, just a little bit lower. But there you go. All right, so hopefully that helps you out with working through exercise 9H. Good luck, and let me know if you need any help.